Right, so we are accumulating quite a lot of skills. We know how to use the mole equation, and we also looked at how to use ratios in chemical equations to work out how much reactant we would use and how much product would be formed. So usually these kind of questions, these calculations involve the use of moles and ratios. So we need to look at a worked example and go through it carefully. And there are two methods that we can use to solve these kind of problems, and we'll go through each of them. So, things to remember: the big numbers, remember, in front of each of the reactants and products tell us the proportions in moles of the substances that react. This is why we balance equations. So this tells me that 1 mole of magnesium reacts with 2 moles of hydrochloric acid to produce 1 mole of magnesium chloride and 1 mole of hydrogen. Okay, just make sure that's clear because it's a very important point. It's a ratio of moles in the reaction. Right, so let's have a look at a particular example of quantities. So in this equation, as we've just said, the ratio is 1, 2, 1, 1. So how many moles of magnesium chloride are produced when 5 moles of magnesium react with excess hydrochloric acid? We'll talk about that in a second. So 5 moles of magnesium would produce 5 moles of magnesium chloride because it's the ratio we're interested in. Okay. 1 mole of magnesium gives 1 mole of magnesium chloride, so 5 moles of magnesium give 5 moles of magnesium chloride. Now, this is important and it will come up quite a few times, the idea of excess and limiting reagent. Now, the term excess means that something in the equation, usually one of the reactants, if it's in excess, then we've got more than enough to react. Okay, so here the hydrochloric acid was in excess. That means we've got lots and lots of hydrochloric acid. It will not be used up. However, the magnesium here was considered to be the limiting reagent or the limiting reactant. The magnesium gets used up, so we drop some magnesium ribbon into hydrochloric acid, the magnesium would completely disappear. So the magnesium is the limiting reagent. And because it's the limiting reagent, it determines how much of each of the products are formed. Because it's used up, once it's used up, no more of the products can be formed. So as we've just said, the limiting reagent here was magnesium. Let's have a look at masses and moles in this same question. If we react 36 grams of magnesium with excess hydrochloric acid, what mass of magnesium chloride is produced? So it's the same equation, obviously, and we've got to make sure we balance it before we start working with it. The equation tells us that 1 mole of magnesium reacts with 2 moles of hydrochloric acid to produce 1 mole of magnesium chloride and 1 mole of hydrogen. Great. But in this case, we haven't got 1 mole of magnesium. We've got 36 grams of magnesium. So the first step is going to be to find out how many moles of magnesium we have. We need the mole equation. You know that number of moles is mass over molar mass. In this case, the mass that we've got is 36 grams. The molar mass of magnesium is 24. Therefore, the number of moles of magnesium we have is 1.5. Makes sense? 1.5 moles of magnesium. Now, From the equation, if 1 mole of magnesium reacts with 2 moles of hydrochloric acid to give 1 mole of magnesium chloride and 1 mole of hydrogen gas, then 1.5 moles of magnesium, which is what we've got in this case, would react with 3 moles of hydrochloric acid, same ratio, to produce 1.5 moles of magnesium chloride and 1.5 moles of hydrogen. So if we know we're making 1.5 moles of magnesium chloride, then 1.5 moles of magnesium chloride has what mass? We go back to our friend, the mole equation. We're going to have to find out, before we use the equation, the molar mass of magnesium chloride, the relative formula mass, remember. How do we do that? Well, we add up the relative atomic masses. So 24 for magnesium and 2 chlorines, 2 times 35.5. Carefully, we work out that 95 grams of magnesium chloride is 1 mole of magnesium chloride. Great. Let's look at the mole equation. We're looking for mass in this case. So we know that the mass is the number of moles times the molar mass. We know we've got 1.5 moles of magnesium chloride. We know the molar mass is 95. So in this reaction, we expect 142.5 grams of magnesium chloride to be produced. Okay. There is another way to do this kind of problem. Let's have a little look at this. And it refers back to what we did when we talked about the ratios of the relative atomic and molecular masses in equations. We're going to call this second method reacting masses. So if we take the equation again, same equation, then we work out how much mass of each of the things that's in the equation, the reactants and the products, they actually have. Magnesium is 24 grams. 24 grams of magnesium is 1 mole. 2 moles of HCl is, well, 1 plus 35.5 times 2, 73 grams. Magnesium chloride, if you work out what mass we've got here, we've got 24 plus 2 times 35.5, which is 95 grams. And we've got 2 grams of hydrogen, 2 times 1, 2. Let's make sure that we've got the right amount of mass on the left-hand side and the right-hand side. So 24 plus 73 is, what, 97, isn't it? And 95 plus 2 is 97. So the law of conservation of mass works out here. So these are reacting masses, and they're also in a ratio. The ratios here will be respected regardless of how much we have of each of the substances. But we haven't got 24 grams of magnesium, we've got 36 grams. 24 grams of magnesium produces 95 grams of magnesium chloride. So 36 grams of magnesium would produce X grams of magnesium chloride. 24, 95, 36, and X. It's a proportion, isn't it? So we'll do a little bit of mathematics. X would be equal to 95, or 36 times 95, divided by 24. That works out to be 142.5 grams of magnesium chloride, which is the same answer as before. So we have the moles method, which is the first method we looked at, and then this method, the reacting masses method. Both of them will work. Essentially, they're both the same mathematics. Let's have another look at how to use these. Let's do another question together. So 200 grams of calcium carbonate reacts with an excess of hydrochloric acid. We need to follow the steps indicated. So first, a balanced equation. Calcium carbonate plus HCl. Calcium carbonate, I'll be careful here. Carbonate ions have got a charge of 2-. Calcium has a charge of 2+, so we need one of each. And that goes back to our formula writing skills. HCl, 1+ and 1-, they balance perfectly. They give me calcium chloride. Ca is 2+, and each chloride is 1-, so we need 2 of them, plus H2O plus CO2, which we've seen before too. Now you'll notice, with your keen chemical eye, you'll notice that this equation is not balanced. We've got 2 chlorines here, and we've only got 1 here. We've got 2 hydrogens here, we've only got 1 here. The rest seems to work. 1, 2, 3 oxygens, 3 oxygens, 1 carbon, 1 carbon, 1 calcium, 1 calcium. So there's a simple way of making sure that this balances, and that is to put a 2 in front of the HCl. And now it balances. Okay. Second step says calculate how many moles of calcium carbonate there are. So you know that we're going to use the mole equation. Just going back to the first step a second, this equation, obviously using moles, 1 mole of calcium carbonate, 2 moles of hydrochloric acid produces 1 mole of calcium chloride, 1 mole of water, 1 mole of carbon dioxide. So 1 mole of calcium carbonate produces 1 mole of carbon dioxide. That's important. We're going to use that fact. But how many moles of calcium carbonate do we have? Well, we need our friend, the mole equation, don't we? So the number of moles is the mass you have divided by the mass of 1 mole. Mass divided by the molar mass. We've got 200. That comes from the question. The molar mass is 40 for calcium, 12 for carbon, and 3 times 16 for the oxygens. So it beautifully works out, the denominator here, to be 100. 200 divided by 100 gives me 2 moles. I have 2 moles of calcium carbonate. Okay. Okay, on to part 3. So 1 mole of calcium carbonate produces 1 mole of carbon dioxide. Therefore, 2 moles of calcium carbonate, 200 grams is 2 moles, produces 2 moles of carbon dioxide. Point 4 requires us to calculate the mass of the carbon dioxide produced. Now, if we've got moles and we want mass, we're going to use, yes, you guessed it, the mole equation. We want mass, so mass is number of moles times the molar mass. The mass of 1 mole. The molar mass of carbon dioxide is carbon plus 2 oxygens. We're going to multiply it by 2 because we want 2 moles. 44 times 2 is 88 grams. So 88 grams of carbon dioxide would be produced by reacting 200 grams of carbon or calcium carbonate with hydrochloric acid. Okay, time to do a few more questions. Have a look at the pages and do the questions. There's also a mention of limiting reagents for you to practice that idea on these pages. Good luck.